All right, I am here to answer questions for the next hour or so, 55 minutes, and then we'll start the test. So, questions? If not, you're going to sit here for an hour and wait, because we're not starting till 2. Give me a problem. I forgot my book. So, can I? Thank you. So 2.4, number 15, is that what you're saying? Oh, yeah, okay. So y equals v cubed minus 2v square root of v all over v. So there's actually several approaches to this. It falls in 2.4, which is the product and quotient rule. So you might be thinking, I can do quotient rule here because you have a quotient, right? Right? Like an f over g. You also have a product, and I'll highlight that in red here. You have product right between that v and the square root of v. So you could have a product rule combined with a quotient rule, which could turn into be kind of ugly. However, if you recognize that 2v square root of v is the same as 2v times v to the 1/2 over v. So I haven't done any derivative yet, right? What's v times v to the 1/2? You add the exponents, right? So 2v to what power? 3/2 all over v. Now, doing that, if you're going to do quotient rule, you just saved yourself having to do the product rule, didn't you? You don't have to do product rule on that. But I'm actually not even a fan of the quotient rule here, because you have 2 terms in the numerator, don't you? And how many terms in the denominator? 1. And anytime you have 2 terms over 1 term, or 3 terms over 1 term, 5 terms over 1 term, you can split it into separate fractions. So I could actually go and do my v cubed over v minus my 2v to the 3/2 over v. And v cubed over v is v squared minus 2. Now how do I do v to the 3/2 over v? What do you do to those powers there? Subtract? Yeah. So 3/2 minus 1 is 1/2, isn't it? And isn't v to the 1/2 the same as square root of v? Now the only reason I put it back to square root of v and I didn't leave it v to the 1/2 is because I know what the derivative of the square root of something is. I'm comfortable with that. If not, if it would have been like v to the 1/3, I would have left it as v to the 1/3. So my y now is this very, very nice, clean function. And if I go for the derivative now, I get 2v minus 2 over 2 root v. And that's because derivative of the square root of v is 1 over 2 root v, right? And then the 2's are going to cancel. So my final answer is 2v minus 1 divided by square root of v. That's how to do that problem without doing any product rule, quotient rule, anything like that. Yes? If what on the test, what? I would say that would show me that you're not just being a robot. Like, I see fraction, I do quotient. You know what I'm saying? Like, you're actually thinking a little ahead and looking at what you have. So I would prefer this to be worked out this way. But if you do it using quotient rule, I'm not going to count it wrong. So would you like to see this done quotient rule style instead? Just to see the difference. Now look how clean our answer is there. It's very nice, right? Let me go back up to, let's take the top right here. Can we assume that, or can I assume that you would have at least been able to get it to there first before you do quotient rule? Is that all right? Okay, so I'm going to start with that and redo this problem. Y equals v squared minus 2v to the 3/2 over v. So this is assuming that you started the problem by putting that v root v together. And so now we're going to look at the numerator as being your f, your denominator as being your g. And remember then the derivative of y will be f prime g minus g prime f all over g squared. All right, what is the derivative of f? That top left corner of our answer. So what's the derivative of the numerator? So what's the derivative of v squared? 2v minus, now you have to kind of like cover up the 2, right? And what's the derivative of v to the 3/2? 3/2 comes down. What happens when 3/2 comes down? Hits the negative 2 and becomes just a 3, right? That's 6 over 2. So 3, and it's minus. So minus 3, v to what power? So take 1 away from 3/2, and what do you get? 1/2. Okay, that's just f prime, isn't it? That's f prime right there. What do I still need? My g, what's g? V, that's the bottom, minus the derivative of the bottom. What's the derivative of the bottom? 1 times the top, v squared minus 2v to the 3/2. Yes. How did I get v squared? Ah, shit. Why didn't y'all say something? I wrote the wrong problem. I wrote it down wrong to start. Did I? Okay, it's not going to change too much here, okay? The problem was I wrote this down wrong. That was supposed to be v cubed. It was supposed to match that one up on the top right there, v cubed. I apologize. Let me fix it. All that changes is right here, right? This derivative would have been what instead? 3v squared. And then over here, v cubed here. All over v squared. So there's your g prime, there's your f, and then the bottom is your g squared. So everyone's okay where all that came from, right? That looks nothing like that super clean answer, does it? So this is something I'm going to state once everyone gets here, but I may as well say it again. One of the things you need to challenge yourself to do is to go back and try and get all your answers that you did for your homework problems to look like the back of the book. Because I'd say a good 30 to 40% of this class is your ability to take a derivative and then simplify it. And the simplification requires a lot of algebra, and you need to get good at that algebra. So on this test, I would count this 100% correct if you gave me that answer right there. Because all I'm doing is just making sure you can apply the rule properly. Next test, I'm going to make sure you can simplify. All right? But I am going to clean this up because I'm not happy leaving it like that. So I'm going to go ahead and take this v here and distribute it through here. So what's 3v squared times v? 3v cubed minus 3v to what power? 1/2 times 1 is 3/2, right? So you're doing a v times v to the 1/2 is v to the 3/2. Then what do I have? Minus v cubed and plus 2v to the 3/2 all over v squared. Now I have some like terms, don't I? My v cubed terms can group together or combine, and my v to the 3/2 terms can group together, right? So I can get how many v cubes? 2, right? V cubed. How many v to the 3/2? -1, so negative v to the 3/2 all over v squared. I have two terms on top of a single term. I'll split it into two fractions. What's v cubed over v squared? Just a 2v there. And then when you do 3/2 and you take away 2, that's 3/2 minus 4 over 2. That's -1/2, isn't it? I'm talking about the power that you would get when you do this part right here. And so I should get a v to the -1/2. So minus v to the -1/2. But raising to the -1/2 means 1 over it, right? And 1 over v to the 1/2 is the 1 over the square root of v. So it's the same answer, isn't it? Same answer. Okay, good. Next question. Same section. F of t equals 2t over 2 plus root t. Now on this one, can you split this one into two fractions? No, you cannot. If you have a single term over two terms, you can't split apart. If it's the other way around, you can. But here we can't. So we're kind of forced right now to use the quotient rule. So f prime of t, and you know, someone might argue with me that this is bad notation, using f and g, because f is already defined as my function, right? But without loss of generality, in other words, without being too anal about it, I'm just making sure we understand that that's the pattern we have, f over g, quotient rule. So what's the derivative of the top? 2 times 2 plus root t. So that's your f prime g minus now your g prime. What's the derivative of the bottom? Okay, good. So the 2 on the bottom is a constant. Derivative of that's 0. So you don't have to look at it. The derivative of the square root of t is 1 over 2 root t. So that's your g prime times f all over your g, which is the denominator, squared. This is 4 plus 2 root t minus root t all over 2 plus root t squared. So all I did there was took this right here, the highlighted yellow. The 2's cancel each other out, right? T over root t is root t, right? T to the first power over t to the 1/2 power is t to the 1 minus a half. 1 minus a half is a half. So t to the 1/2. Right? Oh, wait a minute. Hold on. There's more that happens here. Do y'all see? Do y'all see what's going to happen here? Or wait, no, it doesn't. Oh, well. For how many root t's do I have there? I have 2 of them. Take away 1, right? So it's just a root t. All over. Hey, is this 4 plus t? Hell no. That's not. That's wrong, right? You don't square, whenever you have 2 terms, a binomial squared, you don't just square both terms, right? You have to FOIL it out. And we're not even going to FOIL it out, right? We're just going to leave it. 2 plus root t squared. Next. '21. So this, I'm gathering from the questions I've been getting for the last 2 days from students in this class that this 2.4 was the trouble section. Okay, let me just show you what I would do. All right, and then I'll do it the way you probably did it. When I look at this problem, I realize that the derivative of secant theta is secant theta tangent theta, right? And I'm not real happy with that derivative because it's not very clean, right? I love derivatives of sine and cosine because they're a lot cleaner. So I'm thinking that maybe I can do this, and I'm just going to try it, okay? I don't know if it's going to work. I'm going to rewrite secant as 1 over cosine, because isn't that what it is? And then I'm going to take this, and I'm going to multiply the top by cosine theta, and multiply the bottom by cosine theta. So what do I get on the top when I multiply by 1 over when I multiply cosine theta times 1 over cosine theta? I get 1 over cosine theta plus 1. Because this cosine theta distributes through, doesn't it? I like that. I like that a lot. Because if I look at this right now as being my f and my g, my derivative of f is easy. My derivative of g is easy, isn't it? So let me go for this now. F prime theta equals quotient rule. Derivative of the top, 0 times the bottom. It's not going to matter, is it? It's going to go away. Minus derivative of the bottom, negative sine theta, and then derivative of 1 is 0, so I don't need anything. Times what? 1, right? Remember, this is f prime g minus g prime, don't forget f, right? All over g squared. So all I'm left with now, on the top, the only thing left is what? Sine theta over the bottom, which is cosine theta plus 1 squared. That's just the way I would have done it, okay? It's not right that way and wrong any other way, but I avoided having to use derivatives of secant there. Now let's do it the way that you probably would have done it. F of theta I'm only showing you that because I want you to always be thinking less like a monkey and more like a human. You know, humans, we try and, well, I shouldn't say monkeys. I saw a monkey on something the other day. Did anyone see that? God, where did I see that? It was a monkey that used like 6 different tools to like get to a beehive in a tree. Anyone see that? No? This monkey like climbed up like a 60-foot tree, seriously, and like used 6 different tools to get to a beehive. First, it was like this huge like stick and like beat the hell out of this thing and breached the tree, and then used like another one to do something else, and another one, and finally like a small one to go in there and get the honey out. I mean, it was just so. Let's say I don't want to put monkeys down here because some of them are pretty freaking smart. We want to be less mechanical, less robotic, right? Machines are pretty much like, if this, then this, do this, then this, you know. We want to be thinking like a human, like, I kind of see something there that maybe would work, and try it. All right, there's my f and there's my g. So my derivative would be f prime g minus g prime f all over g squared. So the derivative of the top, derivative of secant theta is secant theta tangent theta times the bottom, right? Which is 1 plus secant theta minus, what's the derivative of the bottom? Secant theta tangent theta, right? Because the derivative of the 1 on the bottom is 0, plus derivative of secant theta, which is secant theta tangent theta, all times the top, secant theta, all over 1 plus secant theta squared. Now, again, I'm not afraid to try and simplify this. What I'm going to do is I'm going to take this secant theta tangent theta, I'm going to distribute it through here. So I would get what secant theta tangent theta times 1 is itself, plus what's secant theta tangent theta times secant theta? Secant squared theta tangent theta. And then on the other one, I have secant theta tangent theta times secant theta, but I'm subtracting it, so minus secant squared theta tangent theta. I like that. All over 1 plus secant theta squared. And I get some good cancellation there, don't I? And the only thing I'm left with is secant theta tangent theta over 1 plus secant theta squared. That's pretty clean. Could you go further? Probably. But I'm not going to. I mean, you could, somehow, you could get it to turn out to this answer, right? If you worked on it long enough, you could get it to look like that. All right, next one, question. Still have 30 minutes. 23. So y equals t sine t over 1 plus t. You have 2 terms on the bottom, so you can't split this into 2 fractions, right? So what do you think? Quotient? F and G? Yeah, see, the problem with this is when we set up our quotient rule, the f prime right there is the derivative of this thing, right? And that's not a sum, it's a product. So we actually have to figure out that f prime by doing a little product rule maybe on the side. So here's some little scratch work for me on the side. I'm trying to figure out if I have t sine t, what the derivative of this is, right? So I have my multiplication right down here. And we could call it, if we want, maybe h and k. So the derivative of this is h prime k plus k prime h. So what's the derivative of h? 1 times k sine t plus, not minus, right? Derivative of k, cosine t times t. So this is just sine t plus t cosine t. And again, I put that t in front of the cosine so that you don't accidentally think that it's t squared, because it's not. That's just the f prime, isn't it? That's just that part right there. Now, the g prime is easy, isn't it? So I should be able to go now to my answer. It's going to be f prime, which was sine t plus t cosine t, times g, 1 plus t, minus g prime. What's g prime? 1 times f, which is t sine t, all over 1 plus t squared. And again, I'm not afraid. I'm gonna clean this up, because the more you see me clean things up, I think the better off you are. I'm taking sine t times 1, sine t times t, t cosine t times 1, t cosine t times t. So the first parentheses has 2 terms. The second parentheses has 2 terms, so you have to do like a FOIL there. I'm going to get a sine t plus a t sine t plus a t cosine t plus a t squared cosine t. What am I missing? Minus the t sine t. So that's that last term up there in the numerator, right? All over this junk squared. And all of that expanding just helped me cancel that one thing right there. So your answer would be everything that's left on top over everything on the bottom. Next. Numero uno. So this is not product rule. It's not quotient rule. This is the first problem that we mess with chain rule on, right? So there were 2 ways I showed you how to do this in class. I'll do them both here. The first way was to say, okay, y is equal to the cube root of something, right? And the something is the thing inside, which is what? 1 plus 4x, right? Once you do that, you set up a table, and then you find d what, d what? dy du. So what's dy du there? So what's the derivative of the cube root of u? Careful. That's close. Remember, cube root of u is u to the 1/3. So you have to use power rule there. 1/3 comes out. U to what power? Subtract 1 from 1/3, you get negative 2/3. So it's actually, if you move things around here, drop that u down, it's 1/3. What root? Cube root of u squared. That's actually what it is. Then on the other one, you go d what, d what? Du dx. And this is, well, that's an easy one, right? 4. And so your answer, right, your y prime is just those two multiplied together, right? 1/3 cube root of u squared times 4. So all you do is you multiply these two together, this one and this one. And are you done at that point? Nope, you have to then replace the u. And u in this problem was what? 1 plus 4x. So it's got to be 4/3 cube root of 1 plus 4x squared. I just slid the 4 on top, right? That's it. That's the first way I showed you. How do you mean? Okay. You start from the inside and work out, and then multiply up instead of down? That's fine. So the other way to look at it was this. Well, I think you still need to realize this is 1 plus 4x to the 1/3 power. And then to get your derivative, you squint your eyes and you say, I've got power rule on the purple, right? Purple to the 1/3 power. What's the derivative of purple to the 1/3 power? 1/3 purple to the negative 2/3. Okay, chain rule then says go inside and take the derivative of purple. What's the derivative of the purple? 4. Now in here though, you have to put the purple in there, 1 plus 4x. And that's the same answer as what we had up there. Right, because you drop that down. Huh? The way it's written, without the purple, is fine. Like, that right there is perfectly acceptable to me. Although, I mean, it wouldn't kill you to put the 4 over the 3 out in front, you know? Just make it 4/3. That sort of thing. I mean, I'm not going to take off for it, but I mean, yeah. I mean, we're going to be simplifying. So eventually what we're going to be doing is we're going to be taking all these derivatives and setting them equal to 0 and solving them as equations. So that's going to require simplification for that to happen. Okay, 20 minutes. 13 on this page. Good one. All right, the first thing we have to realize on this problem is that the variable in the problem is x, and a in the problem is a constant. All right? And I think I said this in the beginning of class, or it's one of the days in class, that in this textbook, anytime you see like A, B, C, D, those are usually represent constants. Or if it's like capital A, capital B, capital C, capital D, those are constants. Variables are usually X, Y, Z, R, S, T. So the A is a constant. So A cubed is a constant also, right? So you may as well be looking at like the number 10 there. It's just a constant. Is that okay? Well, just to start off, just remember that that's what's going on there. Now I'm going to do this kind of the slow way, the fast way. I have cosine of purple again. What is the derivative of cosine of purple? Negative sine of purple. What's purple? A cubed plus X cubed, right? It's not, don't take the derivative yet. The derivative of purple comes in next. So you go times now, what's the derivative of purple? Careful. Remember, A cubed is like a number, a constant. So what's the derivative of a constant by itself? 0. Right? So the derivative of the A cubed is 0, but the derivative of X cubed is 3x squared. See the difference? Now, check this out. If I change this problem, I want to see how you handle it. What about if y is equal to cosine of A cubed x cubed? So instead of addition, I have multiplication inside. So let's go through this. Y prime equals, again, we have cosine purple, right? Derivative of cosine purple is negative sine purple times the derivative of purple. So let me take the a cubed x cubed over here. I want the derivative of that, don't I? Yeah, the constant a cubed doesn't matter, right? The constant comes out in front. And then you take derivative of x cubed. What's derivative of x cubed? 3x squared. But then you still have the a cubed in front. So it becomes 3a cubed x squared. Do y'all see the difference between those two? Let me see if you really get this or not. What about if y equals cosine of a cubed? What's y prime? The whole answer is 0. Because a cubed is a constant, isn't it? And what's cosine of a number? It's a number, right? It's constant. What's derivative of a constant? 0. Now you could have gotten it by doing this also. Negative sine of a cubed times what's derivative of a cubed? 0. And 0 kills off everything else. You get 0. Where? What? For which one? Which would be this right here. They did what? That's the answer in the back of the book? Yeah, that's the one in the back of the book. The two I did after I just made up. Yeah. Yes, I will do 10. This is a good problem right here. So what do you see happening here? You want to bring the whole thing up as a negative 2? All right. I like it. Let's do it. This isn't the only way to do it, but this is what's been suggested. Do y'all agree with that? Now, do you see chain rule? Do you see purple to a power here? So the derivative of this would be, what's derivative of purple to the negative 2? Negative 2. Purple to the negative 3. Then times the derivative of what the purple is. Secant x tangent x. Right? The derivative of 1 is 0, so you don't have to worry about that. Plus, derivative of secant is secant x tangent x. And cleaned up a little bit, negative 2 secant x tangent x over 1 plus secant x cubed. That is a way to do that problem. Not the only way, but a way. You want me to do a quotient rule? I'm not sure I understand the question. Mm-hmm. Yeah. For this one, if you can see that you can pull that denominator up as a negative 2, you avoid the quotient rule. Now, I want you to see that with the quotient rule, though, because I don't know how many of you are going to want to naturally just do that, what was suggested. So, 1 plus secant x squared. So if I do it with quotient, I call that f and g. Then I'm going to need f prime g minus g prime f all over g squared. How's f prime going to be? It's going to be good, right? No problem? What about g prime, though? G is something squared, isn't it? So to get the derivative of g, you're actually going to have to do a chain rule to get the derivative of g. So I would have to do some scratch work on the side here, and I'd have to ask myself, what is the derivative of this? Right? So this is where you'd have to come in here and say purple squared. What's the derivative of purple squared? 2 times purple times derivative what's in there, right? Secant x tangent x. Do you all agree with that? That's just my little g prime. That's just g prime right there. Questions, because I'm going to finish this one off. F prime we said was what? 0 times the bottom, which isn't going to matter here because it's going to all get canceled and killed off. Let's see, minus g prime. I'll clean up g prime just a little bit. Secant x tangent x times 1 plus secant x all over 1 plus secant x squared. That whole, go ahead, secant x squared. Yes, so that should actually be what power there? 4th power. And what happens now is the 0 kills off that top left. And then I have 1 plus secant squared to the 1st power, 1 plus secant squared on the bottom to the 4th. I can cancel 1, and that'll become a 3rd power on the bottom. And so you'll have negative 2 secant x tangent x over 1 plus secant x cubed, which is the same answer. All right. We've got 10 minutes, so any last requests here? 9, same section. So this is a chain. I have square root of purple, right? What's the derivative of square root of something? 1 over 2, square root of whatever was there, right? 1 minus 2x. Times, chain rule says now you have to go inside and take derivative of what was in there. Negative 2. Yeah, negative 2. And then you'd cancel the negative 2 and the 2 and leave a negative 1 on top. Now remember what I said last class. This test is going to cover chain rule, right? But just the beginning of chain rule. Let me give you an example of something I would expect you to do later. Just so you know, like we're just touching the surface here, okay? How about something like square root of 1 plus the square root of sine of x squared plus 1 over x sine x. Let's just appreciate the horror of this problem here. You have a chain rule in the sense that you've got a square, the last thing happening is square root of something, right? Then inside that is 1 plus the square root of something. Then inside that is sine of something, right? But inside the sine is a quotient rule. And in the quotient rule, the denominator is a product rule. That's where we're kind of going. So appreciate that on this test. That I've always been able to say like square root of purple, great. What's purple? This, that. That's real cute right now. But later on, we can't be cute. We just have to be able to understand it. All right. We'll run out of colors. All right. I still have 8 minutes. I'm not going to start talking about the test until 2 o'clock. 2.4, number 5. This will be the last one I do. And y'all don't get too comfortable because we're going to rearrange everything in just a second. Here, I see product rule. That's like the most natural thing I see because I see a friggin' product, right? I mean, something times something. But the first set of parentheses, the 1 over y squared and the 3 over y to the fourth, those are just powers of y. Right? That's just y to the negative 2 minus 3y to the negative 4. And then y plus 5y cubed. Yes? And I mean, you could do product rule here because if you call this first one f and you call this second one g, I think f prime is pretty clean. Yay or nay? All right, derivative of f would be negative 2y to the negative 3 plus 12y to the negative 5. Then you do times g and then plus g prime f. But I don't really think I would do that problem this way. I would actually not even try product rule. And I would just do a foiling before I do any differentiation. So what's y to the negative 2 times y? Negative 1. And then we have plus 5y. That's what you get when you do y to the negative 2 times 5y to the third, right? You add the exponents. How about that inside one? What's negative 3 y to the 4 times y? Negative 3 y to the negative 3. And then what's the final piece you get there? Negative 1. Do you see that? And now this is just 1, 2, 3, 4 terms. And the first, actually I just noticed this, the first one and the last one are like terms, aren't they? So I could go one more step. 5y minus 3y to the negative 3 minus 14y to the negative 1. That's what this function is to start. Now, if you did product rule, you're probably already done. But why is this going to be a little bit better, do you think? I assure you my answer is going to be much cleaner than yours will be. See, there's my derivative right there. Did that make sense, what I did? Yes? Okay. So I avoided the product rule because I realized I could get everything down to powers of y, and it would be nice. All right. I think, let me stop my recording.